lasers are firstly introduced in early 1960s. When the first laser device this has been developed in early 1960s. These laser devices are now very advanced, and they are even farther from the development of the first laser device that we got in 1960s. And even when these lasers are coupled with the fiber optics, these are coupled with the semiconductor optoelectronic devices, these opens up a new era of technologies. This technology, it is likely to be revolutionize the world of industry and technology in the next few years, because the first laser device that we get in 1960s, but its theoretical basis that we found in 1917, that is by the Albert Einstein. When Albert Einstein was studying the interaction of matter with the electromagnetic radiation, he found three processes that how electromagnetic interaction can interact with the matter. And experimentally we find the laser in 1960s, but the theoretical basis of interaction of matter and electromagnetic radiation was found in 1917 by Albert Einstein. And what is that? So it can interact via three processes. So what are these three processes? First process is the stimulated absorption, and in that case we see when you have a matter and when you incident light on it, in that case, so that light photons can be absorbed. So it can be absorbed by the atom that is present in the ground state, and that atom, after absorbing that light photons, can go to the excited state. So when a light photons come, it is interacting with the matter, so it can absorb this light, and then will have this electron in now in the excited state. So this process of this transition is named as the stimulated absorption, and we use stimulated word when we are giving some external energy, and we are giving this external energy in form of the photons here. So after absorption, you see your electron will be in this excited state. This is how a photon is interacting with the matter when electron is in the ground state. So this is a stimulated absorption, and this is the case before absorption of that photon, and after the absorption of that photon, now the electron is in the excited state. So, and the next second process is the spontaneous emission. Some of electron may be now in the excited state because they are absorbing the light. So when these are in the excited state, so they can come back to the ground state by itself. So when these electrons present in this excited state have that lifetime state, it is 10 power minus 8 seconds. So if it is remain on the excited state on the 10 power minus 8 second, which is very less, and they can come back to the ground state by itself by the emission of photon. So this type of emission, we named it as spontaneous emission, because we have not given any kind of energy from the outside, and these excited electrons are just coming down to this ground state by the emission of photon. And this emitted photon, in case of the spontaneous emission, that is incoherent photon, because it can move in any direction. So that random direction motion of this photons, that due to this spontaneous emission, leads to the incoherent light that we are getting from the source. So that light is the incoherent light source when we get from the spontaneous emission, and even they are not related to the internal and external condition of the system. What material you have used for the laser system, they don't care about what internal and external condition, but if there is a spontaneous emission takes place, they will go in the random direction. That leads to the incoherent light sources, and other conventional sources other than the laser sources, they emit incoherent light, because light goes in the all directions, and they are not in phase with each other, so they are not related to each other even. So that light is the incoherent light sources. Next, third, stimulated emission, because in case of stimulated emission, we say we have the electrons that is in the excited state, but that excited state, which is the metastable state, and that state is where the lifetime of that electron is very high. So this electron is now not ready to come back to this ground state because its lifetime is now 10 power minus 3 seconds. Earlier, when we are talking about spontaneous emission, its lifetime is 10 power minus 8 seconds. It's around 10 power 5 times more than that state. So when these electrons are have been excited to the state metastable state, so they are not ready to come back. So when you are giving some energy from the outside, so what will happen? These electrons are now coming back to the ground state by the emission of two photons here, because first photons that you have given at the input, and other photon that you are getting is from the this transition that takes place to conserve the energy. So in this case you are getting the two photons at the output, and these two photons are coherent to each other, means they have same frequency and even they are parallel to each other, in phase with each other. So that light we get is a coherent light, and that coherent light we get only in the case of stimulated emission that has been takes place in the matter and the electromagnetic interaction. This is a stimulated emission that occurs in the lasers. We know that what is a laser? The light amplification by the stimulated emission of the radiations. So if they have the same frequency and in phase with each other, so that light sources are coherent light sources, and laser is a coherent light source. And other conventional sources that we use, they are incoherent light sources because they are giving the light in all directions. You will get the very less intensity of light sources when your light is incoherent, because when you are getting the coherent sources, you can even confine these light sources to a very small area of dimension. So when you can focus these lights on very small area and your intensity at that point, you will get very high intensity and high power laser systems that has been used. They can be used even in welding or even for cutting the substances, and even those are used surgical operations that we use the lasers. What's the main other difference is that we get monochromatic light from the laser sources,